NASA's Voyager 1 spacecraft is the most distant human-made object. It has traveled into interstellar space, a remarkable achievement since its launch 45 years ago. Imagine a spacecraft, still exploring areas that were never thought possible, well beyond its original lifespan. This is the incredible reality of a bold NASA mission that is changing how we view space exploration. What makes Voyager 1 even more fascinating is that it is millions of miles away from Earth. Despite this distance, it continues to send valuable data back to us. The technology it uses is older than a cassette player, yet it still works effectively. Launched in 1977, Voyager 1 recently made a discovery that has surprised scientists and captured the world's attention. What could this amazing find be, and what does it mean for us here on Earth? In the late 1970s, two of the most remarkable space missions were launched. These missions marked the beginning of a new era in space exploration. Thanks to the brilliant mind of Gary Flandreau from NASA's Jet Propulsion Laboratory, a perfect route was mapped out for the Voyager probes. This route allowed them to reach distant planets like Jupiter, Saturn, Uranus, and Neptune. Flandreau made a startling discovery: the four gas giants would align in a unique cosmic configuration. This alignment created a kind of celestial necklace with Earth. It allowed spacecraft passing close to each planet to gain speed through gravity assists, as if pulled by an invisible rope. This meant that a journey that would normally take 30 years to reach Neptune could be reduced to just 12 years. However, this alignment only occurred once every 176 years. Faced with such a rare opportunity, NASA acted quickly. Just 15 days apart, they launched two identical spacecraft, Voyager 1 and Voyager 2, in the summer of 1977. They aimed to take advantage of this cosmic alignment. Little did they know that these twin explorers would break all records in the history of space missions. More than 45 years after their launch, Voyager 1 and Voyager 2 are still operational. They send back information daily from the edges of our solar system. These probes have become the farthest ships in history, traveling far beyond what was initially imagined. This is impressive, especially considering that their original mission was planned to last just 4 years. The Voyager spacecraft had many surprises in store. At the start of their journeys, they provided us with incredible close-up images of the moons of Jupiter and Saturn. These images revealed worlds that were far more active and dynamic than scientists had anticipated. Their discoveries of active volcanoes and ice fields changed our understanding of these distant corners of the solar system. Voyager 2, in particular, was the first spacecraft to approach Uranus in 1986 and Neptune in 1989. It became the only probe to exist between those planets, surprising scientists with astonishing findings in previously unexplored territories. More than 14 billion kilometers from Earth, these Volkswagen Beetle-sized probes have defied all expectations and continue to expand the boundaries of our knowledge. The Voyager journey began with a gravity assist maneuver around Venus. This was a feat never before attempted by any spacecraft on its route to Mercury, making them true pioneers. The journey to Jupiter took the spacecraft 10 times the distance Mercury is from Earth. They had to pass through the dangerous asteroid belt, a challenge previously tackled by Pioneer 10 and 11 probes. But the challenges didn't end there. With only 69 kilobytes of memory, a fraction of what a modern smartphone has, the onboard computers had to rely on their own intelligence. They managed the complexities of this extraordinary journey. Data collected by instruments aboard Voyager was stored on track tape recorders before being transmitted to Earth. The transmitter used only 23 watts, about the same power as a light bulb. These probes were equipped with 12-meter diameter satellite dishes to facilitate communications. They used light-speed radio to send and receive messages. However, as they traveled farther from Earth, the distance presented major challenges. For example, signals from Voyager 2 took more than 18 hours to reach Earth. The increasing background noise from radios, televisions, cell phones, and other sources made it harder to pick up the faint signals from the spacecraft. Despite these obstacles, the Voyager probes have continued to amaze astronomers with unexpected discoveries in an interstellar void. Their journey has rewritten our understanding of the cosmos and changed our view of the unknown. Beyond our solar system lies the Oort cloud, a vast congregation of comet-like objects held together by the Sun's gravity. This region stretches to the nearest star. Although the Voyagers are still moving slowly toward this distant realm, their entry into interstellar space began when they crossed the heliopause. This boundary separates our solar system from interstellar space. Initially, the heliopause was estimated to be about 50 astronomical units from Earth. NASA decided to continue funding the mission even as it approached this milestone. However, crossing this boundary did not show an immediate change in the environment, leaving scientists puzzled. The passage into interstellar space was expected to bring an increase in cosmic rays, high-energy particles traveling at nearly the speed of light. These cosmic rays are ejected by supernovae and other cosmic phenomena. However, most high-energy rays are deflected by the magnetic shield generated by the heliosphere. This shield protects our solar system from most external threats. The Voyager missions team closely monitored any changes in the prevailing magnetic field as the spacecraft moved into the interstellar medium. The interstellar medium is composed of ionized gases and is influenced by nearby stars. Scientists expected the interstellar magnetic field to be oriented differently compared to that of the heliosphere. However, the Voyager probes did not detect any significant changes in the magnetic field. On August 25, 2012, Voyager 1 finally crossed the heliopause. It transmitted fascinating data confirming an expected increase in plasma density. However, there was no evidence of a change in magnetic fields. This was surprising because scientists anticipated that moving from a region dominated by solar energy fields to one influenced by other stars would show noticeable variations in the magnetic field. The data from Voyager 1 confirmed some changes, but not in the way scientists expected. These findings opened up new questions about the nature of space and our understanding of the boundaries of our solar system. The Voyager missions have not only expanded our knowledge but have also sparked curiosity about what lies beyond our solar system. As Voyager continues its journey, it serves as a reminder of human ingenuity and the spirit of exploration. The discoveries made by these spacecraft have inspired generations of scientists and space enthusiasts. They have shown us that there is still so much to learn about the universe. The Voyager missions have also highlighted the importance of international collaboration in space exploration. Scientists from around the world have worked together to analyze the data sent back by these probes. This collaboration has led to a deeper understanding of our solar system and beyond. In conclusion, the Voyager missions are a testament to what can be achieved with vision, determination, and teamwork. They have pushed the boundaries of human knowledge and have opened our eyes to the wonders of the universe. As we continue to explore space, we can only imagine what other discoveries await us. If you enjoyed this content, don't forget to hit the like button and subscribe. Your support helps us continue creating more insightful content. Subscribe to our channel and thanks for watching.